Chapter 16, we're going to learn about pH and also the indicator. So our first video, 16.1, we're going to introduce what is pH scale. First of all, we're going to take a look of what is pH. So pH actually in our daily life, we can always see them. Okay, for example, this body wash. So you can find that, okay, the pH is 5.5. What is pH then? Before we learn that, okay, we have to know that in aqueous solutions, okay, all the aqueous solutions actually we know that, okay, they contain water. Okay, but for the water, actually it can be ionized, okay, into H plus and OH minus. You can do like this. Okay, so actually from time to time the H2O, it will lose one of the hydrogen ions, okay, and then become OH minus. But these hydrogen ion will then combine, okay, maybe with another OH minus to form water again. So this process is pretty quick. Okay, they will back and forth like that. So as long as you got water, actually you should have H plus ion in it and also OH minus ion in it. So strictly speaking, all aqueous solutions, they must contain H plus and OH minus, no matter you are acid or alkaline. Okay, so then how can I know that it is acidic or alkaline? So the acidity and alkalinity, actually it depends on the difference, okay, between the H plus and OH minus. If we have a neutral solutions, you can have a look here. If it's neutral solutions, the H plus concentrations have to be equal to the OH minus. So at that time, okay, they will be equivalent. You can just have a look of this example. When one H2O, they try to ionize, they will give one H plus and one OH minus. So in this case, you'll find that the H plus concentration will be equal to the OH minus. But imagine if I add HCl into this water, then at that time HCl will be ionized into H plus, and then you have a Cal minus. At this moment, you will find that H plus will then be more than the OH minus. Okay, so at that time, if you have H plus concentration more than the OH minus, you are acidic. Get it? So if you have H plus ion more than OH minus, that will be acidic. But on the other way around, if you got H plus ion less than OH minus, that means you got more OH minus. Okay, for example, okay, I have NaOH adding in it, then at that time maybe you have more OH minus, okay, than the H plus. Then at that time, okay, you will find that the solutions will be alkaline. Okay, so if you know that, okay, so we'll always have some statement asking you that is true or false. Okay, you can check these two questions. Question number 1, you can have a look. Acid has only H plus ion, but not OH minus ion. Okay, so all the time when you have only, you have to be pay attention. Is it really only that? Okay, so just like we said that, okay, as long as you got water, you should have both ion in it. Just acid, okay, you have more H plus than OH minus. It doesn't mean that it doesn't have any OH minus. So this statement should be false. Second one, there is no H plus ion in NaOH. Again, okay, if this one is an NaOH solution, that it must have H plus ion in it. Okay, so this one is false as well. Okay. Okay, so we know that, okay, H plus ion more than OH minus, then it will be acidic. But always, okay, we use a value pH to describe, okay, this solution is acidic or alkaline. So what is pH? First of all, okay, pH actually is a mathematical terms. Okay, it means that P stands for the negative log. H is talking about the H plus ion. Okay, so right here, okay, you will find that pH actually is stand for negative log H plus ion. Okay, so you can see a square bracket right there. Square bracket, actually you use it to describe the molar concentration. That means capital letter M. Okay, so if we have a molar of H plus, I know that maybe 1 molar, then I put 1 molar here, and then we have negative log for that. So the pH, you have to notice that it has no unit in it. So for this, okay, we have to learn how to input in your calculator. So if you want to do first question 0.01, what you need to do is just basically input negative log 0.01, and then you press execute. Then you can find the results for this one. Okay, this one, okay, the pH should be 2. or while the other one 0.1 m and 1 m. Okay, so you can pause the video and have a look. Okay, calculate it. What is that? So the answer for this, okay, should be pH 1 and also pH 0. Okay, I think better add pH right there. Okay, so from here, okay, you can see that, okay, it is quite interesting. If you have like the pH decreased by 1, this one decreased by 1, this one decreased by 1, okay, you will find that actually the concentration is increased by 10 times. Okay, first of all, you see that the relationship, okay, they are inversely proportional. Okay, that means more H plus, lower the pH. Okay, secondly, okay, because this one is based on log, okay, so therefore whenever the values of pH decrease by 1, the concentration will then be increased 10 times. Okay, so this is the properties of the pH value. So the other side, okay, if we try to use a pH and then convert it into H plus, how should we do the math? Okay, so you can see that actually the opposites, okay, you reverse, okay, or rearrange the terms, okay, the mathematical terms, okay, you have this equation. But actually this equation is quite difficult for you to memorize, so you just input 1 right there and then do the rest will be all right. So when you have pH 1, okay, what should you do then? Okay, so first of all, okay, we'll have, because the log will be on the other side, okay, we have like 1 equals to negative log H plus, right? So what we're doing, okay, we have to put the log, okay, from the right hand side to the left hand side. So therefore we'll have like shift log, and then you put the negative from the right to the left. Okay, you put the negative right here already. You put the negative here first, okay, and then you put the log on the side. So therefore you will shift log negative 1, okay, and then execute. Okay, so this is how you input the data, okay, in your calculator. So for the answer for pH 1, you'll find that, okay, it will be 0.1 molar, or pH 2 will be 0.01 molar, and pH 3 will be 0.001 molar. Okay. So again, you can see that, okay, if the pH increased by 1, okay, and then the concentration of H plus will decrease 10 times. Okay, so basically you have to know how to, when you're given a concentration of H plus, you have to know how to calculate the pH or vice versa. So let's have a look of some exercise. Calculating the pH value of an aqueous solution of the acid, okay, from its H plus concentration. So we are going to calculate the pH. Part A is pretty easy, okay, because you have like the molarity, and that will be HCl. Because we are talking about the molarity of HCl, okay, we're talking about this one, HCl. But remember, okay, the equation, we are going to find out the negative log of H plus only. We are not talking about HCl. So actually you have to go down to this level, okay, you have to go down here. But HCl, we just have one H in it only. So therefore it's pretty easy. It will be a negative log 1 times 10 to negative 4 and then times 1, because you have 1 H in HCl. Okay, so by doing this, so you can find that the value should be 4.0. Okay, so that is part A. Okay, part B is more important. You can find that, okay, this time, okay, what we are doing with is a dibasic acid, is H2SO4. So for part B, okay, you have to pay attention. Okay, we have pH equals to negative log. The H plus this time, it will be 2 times 10 to negative 4, okay, which is given from the data. But remember, this one is dibasic acid, so therefore you have to times 2, okay? So the whole things will have to times 2. So if you put it in the calculator, you'll find that it should be pH, okay, should be 3.4. Okay, that's correct. Actually, pH is not necessarily a whole integer. Okay, it can be decimal places as well. So example 16.2. This time we give you H plus, okay, and ask you to calculate the pH value. We give you a pH, okay, and then calculate the H plus. So the first one, A, okay, it should be pH equals to 2, okay, then it will be negative log H plus. So remember, when you do the calculations, okay, you should be shift log negative 2, and then execute. Remember that negative, okay, is right in front of 2, okay, not negative shift log, okay, the other way around. So the concentration for this one, okay, it should be 0.01 m. While second one, okay, part B, okay, 5.5 equals to negative log H plus. So for this one, okay, you'll find that H plus should equals to 3.16 times 10 to the negative 6 m. Okay, so this is how we do the calculations. So you can have a look of this class practice as well. Okay, so basically this one is just echo what we've learned just now. When you have 0.01 m and then 0.1 m and then 1 m, okay, we'll find that, okay, the pH value will go by 1, okay, because it is increasing by 10 times. Okay, you see that right here, it is increasing by 10 times. Okay, increase by 10 times. So the first one, okay, when it is 2, then it will be 1 and then 0. Okay, so our 0 is also a pH value, so we pay attention to that. Okay, and then for part D and part E, we just want to pay attention to a dibasic acid. So for part E, okay, part E, you have to remember pH equals to negative log 0.1 times 2, okay, for this one, part E. Okay, so the answer for this one should be 0.70. Get it? No unit for pH again. So this one, okay, we will then see that, okay, we have a pH scale. This one is from your textbook. Okay, you will find that the range will be from 0, remember we have 0 through 7, okay, and then go to 14. Or the most common daily commodity, okay, you will be find within this range from 0 through 7, which is in the center, okay, that will be the neutral solution, and then it will go up to 14, okay. The further away from 7, okay, we call that stronger. Maybe you say stronger acidic, strongly acidic, not stronger, strongly acidic or strongly alkaline. While the one slightly in the middle, you will say slightly acidic or slightly alkaline. Get it? Okay, so for example, like black coffee, like Coca-Cola, okay, then for those, okay, they will be slightly acidic, okay, but for the hydrochloric acid, gastric juice, okay, or like car battery, you can see the other pictures that I show you, okay, they look much more funny, okay, you have car battery, stomach acid, okay, for the other side we have like drink cleaner with bleach, okay, soapy water, okay, so for these, okay, they will have a very high concentrations, okay, of H plus and OH minus, okay. So right there, okay, you can see that, okay, the pH 1 and pH 0 and pH 1 and pH 2, you can see that actually they will be increased, they will decrease it by 10 times, okay, for the concentration of H plus. Okay, just want to show you this one as well. Remember, okay, the pH calculation so far that we have learned, okay, this pH equals to negative log H plus. pH equals to negative log H plus. We can only solve pH, okay, below 7. Okay, if you input and find that, okay, oh, I got a pH equals to 10, okay, most likely it is incorrect, okay, because the calculation for the alkaline solution is not doing that way, okay. Just a friendly reminders, okay, remember that if pH smaller than 7, that will be acidic, larger than 7, that will be alkaline, okay. So have a look of class practice 16.2, okay. So given that pH values of 4 solutions, describe each of the above solutions using the term highly acidic, slightly alkaline. So remember, closer to pH value 7, that is slightly. So this one is slightly alkaline. Okay, and then pH 1 is strongly acidic. Sorry, I made mistake. This one should be acidic. Okay, and then C and D. Okay, C will be slightly alkaline. And then 7, this one, okay, we'll call this one neutral. Got it? So I'll explain whether this question is very important. Okay, question number 2. Explain the pH value increase or decrease in each of the following cases. For A, okay, we are having magnesium add into HCl. Okay, you have know that, okay, in the process, okay, magnesium will react with the chloride ion, becomes magnesium chloride, but the H plus, they will become H2. So you'll find that in the process of experiments A, okay, the H plus concentration, because all of them, they are turning into H2. So therefore, the concentration of H plus is going down. If concentration of H plus is going down, pH should go up. Okay, part B, okay, when we dissolve HCl gas in water, when we have HCl, when we add it into the water, actually they will have ionization. So in this case, okay, we will know that H plus ion will then increase. So therefore, pH should go down. Okay, got it? Remember, this is a gas, okay? This is not hydrogen ion. So if you just have some hydrogen chloride gas, where you cannot measure the pH of it, okay, until you dissolve it in the water and forming hydrogen ion. So summary for this videos, okay, first of all, you have to know that all aqueous solutions, because they have water, okay, all of them must contain both H plus and OH minus. And the acidity and alkalinity actually depends on the difference between H plus and OH minus. If H plus is larger than OH minus, that should be acidic. But on the other way around, if H plus less than, the concentration is less than OH minus, then that one will be alkaline. Okay, you should learn how to calculate, okay, the pH. Okay, remember the H plus sometimes, okay, you need to multiply by N, especially for the dibasic and also the tribasic acid. Okay, for example, H3PO4, that may be the molarity. You have to multiply by 3. Okay, number 4, okay, the pH decreased by 1. Okay, H plus increases 10 times. Okay, so remember this one is based on log. Okay, it's the base 10. So therefore, when pH going down by 1, okay, they have to increase by 10. Okay, this is a negative. Okay, is inversely proportional. So therefore, one decrease, the other one will increase. pH scales, okay, go from 0 to 14. Okay, forgot one thing I have to remind you. Okay, remember, okay, actually we do have acid, okay, having pH lower than 0. Okay, it's not difficult for you to do. Okay, you can just quick check. Okay, if I have H plus concentration equals to, say for example, 5m, okay, then you can calculate, okay, what should be the pH of it. Okay, so for this one, okay, if you calculate, the pH should be negative 0.69. Okay, so you can see that, okay, actually we can have solutions, okay, with pH lower than zero, that means negative. At the same time, you can also have the pH value larger than 14. Okay, just our daily commodity fall in this range. It doesn't mean that, okay, beyond this range, we don't have those kind of chemicals. Okay, so you also have to take a look of some common daily commodity, okay, in our daily life. For example, tomato, orange juice, okay, stomach acid, battery, car battery acid. Okay, all these things, okay, you have to know whether they are strongly acidic or slightly acidic. Okay, so that's all for this video. Bye bye.